In almost every corner of our Earth, there is life. Our planet is literally teeming with it. All the way down to the thermal vents of the ocean floor, there is life eking out an existence. But there's one place on our planet where life has never been, and yet it affects us every day. A place where life cannot exist, and yet it makes up 99% of our globe. It's the core of our Earth. And here, a smoldering substance about the same consistency as bubble gum churns about in an ocean of molten lava. Now, the core of our Earth is responsible for much more than the occasional volcano. It generates the Earth's magnetic field. This field protects us from dangerous solar winds by which our planet is being constantly bombarded. But lately, this field has been getting weaker and weaker. Now, we're not in danger of it disappearing entirely, but what has happened in the past is that the poles have switched places. In other words, the magnetic North Pole and magnetic South Pole have flipped. This alters our magnetic direction, affects our wind currents, our agriculture, and exposes us to dangerous interstellar radiation. And according to a 2009 issuance by the National Space Weather Program, we may very well be standing on the verge of one such flip. In order to understand more about Earth's magnetic flip, we first have to examine the field itself. Then we can examine what scientists are discovering about this changing epic structure. And finally, examine some implications of what this might mean for the future of our planet, and what a September 26, 2008 U.S. and World News report states will affect every form of life on the entire planet. Now, in order to understand more about Earth's magnetic field, we first have to understand what it's made of, so that we may then take a closer look at how it actually functions. So first, what it's made of. According to a 2009 United States Geological Survey, the main ingredient to the Earth's core is molten iron. Now, iron is interesting because it turns the Earth into a giant magnet, and we're all familiar with the concept of magnetism. Opposite poles attract one another. Well, the Earth's magnetic field extends out of the South Pole, loops around the planet, and re-enters at the North Pole. The shape of this apple is perfect because it demonstrates how the Earth's magnetic field covers most of the planet while denting in at the weaker areas, the North and South Poles. So picture a bar magnet going right through the middle of Earth. Now, if I cut this apple in half, the thickness of the skin represents the crust of our Earth. And as you can see, the majority of our planet is unlike the outer shell with which we are more familiar. Here, molten iron churns about in these oceans and generates the Earth's magnetic field. But what does this field do exactly? Well, much like how this room might protect us from wind and rain outside, the Earth's magnetic field protects us from dangerous interstellar radiation. According to the November 2008 edition of Astronomy magazine, exploding stars and even our own sun are constantly bombarding our planet with electrically charged particles of radioactive plasma called solar winds. Now, most of these particles are diverted harmlessly around our planet thanks to the magnetic field. But a few make their way to where the poles are weakest, the North and South Poles. Here, these particles are burned up in our atmosphere in what is known as Aurora Borealis and Australis. But according to an episode of PBS's Nova, which first aired on September 16, 2003, the strength of our magnetic field is decreasing. In fact, it's decreasing so much that at the current rate, it will only last into the next millennium. However, according to a September 17, 2008 interview with Gary Glucksmeyer, professor of Earth Sciences at University of California, Santa Cruz, he stated that what is actually happening is something that the Earth does roughly every 100,000 years. It flips poles. Much like how you might toss and turn in your sleep at night, the Earth's magnetic field also changes position. Now, why this occurs is not quite understood, but it's causing scientists to scramble in order to figure out both when it will happen next and what actions will take place when it does. So, first, when it will happen next. According to an August 14, 2008 article from LiveScience.com, Jeremy Hsu states that this phenomenon is always preceded by the same occurrence, the weakening of the Earth's magnetic field, just as we're seeing now. Then, after the flip, the poles return to their original strength. And scientists have no idea why. According to another article from LiveScience.com, this one from September 24, 2008, Clara Moskowitz states that the last time this occurred was 780,000 years ago. Now, there have been longer stretches in our Earth's history where a flip did not occur, but with the national average of 100,000 years, it seems that a flip is belated. Many scientists feel that the weakening we're seeing in the structure now is the signal of a long overdue flip. So what happens during this flip? How long does it take? Well, in terms of the Earth's lifetime, it's instantaneous. In terms of our lifetime, it could take 300 years. In a personal interview from February 16, 2009, with Tom Thorpe, project manager from NASA's Jet Propulsion Laboratory, he stated that typically what happens is that the main poles decrease in strength. And then we get little hot spots of magnetic activity all around the Earth. Now, strange to think, but we would have tens, maybe hundreds of individual north poles scattered all around the planet. Some will be weak, while others will be strong. Then, after a few hundred years, these miniature poles will decrease in strength. The main poles will switch places, their strength will pick back up, and our compasses will point south. It's interesting to note that for a few hundred years, we won't have a strong cohesive magnetic field. And according to the previously cited PBS Nova documentary, Mario Acusa, one of NASA's foremost authorities on magnetic fields, states that without a strong cohesive field, much of our planet's atmosphere could be eroded. This would cause a planet which was teeming with life to die out. Many scientists feel this is exactly what happened to Mars's atmosphere, and this makes it all the more disturbing that our own magnetic field is getting weaker. But if life has existed through countless of these flips before, what does this mean for us now? No, this doesn't mean that your toilet will flush backwards, but this will impact our lives in thousands of areas, such as migratory patterns of birds and fish who use magnetic iron in their blood to help them navigate. But of the countless implications like these, two are especially poignant. Number one, the lack of a strong cohesive magnetic field will expose us to more interstellar radiation, and as a result, cancer rates will rise. Obviously, this will have a huge health impact on all of humanity. However, according to a September 26, 2008 New York Times article, the number of these cancer cases will be significant, but not catastrophic. So while the human race won't die out because of these cancer cases, we can expect a shift in the focus of healthcare. Second, one implication which may cause us to have to re-examine many of our previously held beliefs. According to a 2007 study published by the Danish National Space Program, solar winds have been increasing over the past 100 years. Now, this, in combination with the fact that our own magnetic field has been decreasing over the same period of time, means that much of our water vapor has been eroded. Now, water vapor, or clouds, are important because they help regulate the temperature of the Earth. Think of it like this. You're standing underneath the warm, hot sun, and suddenly a cloud passes by and you get cooler. This is because the sun's rays bounce off the cloud and return into space. Water vapor helps regulate the temperature of the Earth. And according to BBC's award-winning documentary, The Great Global Warming Swindle, the polemic rebuttal to Al Gore's An Inconvenient Truth, lack of water vapor on our planet results in a hotter Earth. Global warming. There's no doubt that our planet is getting hotter, but the focus has been primarily on CO2, which is a weak greenhouse gas. Water vapor, which is a much more significant greenhouse gas, deserves a closer look. According to a February 16, 2009 personal interview with Jennifer Kreitow, she stated that the lack of a magnetic field on our Earth would expose us to more UV radiation. Now, UV radiation is particularly good at breaking apart the water molecule. This challenges what we know about global warming and its causes. Many scholars are up in arms about these recent findings. Many scientists insist that human causality is arrogant in comparison with the powers of the Earth and Sun. But whether the Earth's relationship to the Sun is the cause of our planet getting hotter or whether it's our cars, these new findings force us to at least consider the question, what if we don't have as much control over our planet as we think? The Earth is a highly active planet. But by understanding these changes, we gain a more humbling understanding of our own lives. Now today, we examine the Earth's magnetic field. We took a closer look at the flipping of this field. We examined how this will impact our planet. We can't be entirely sure of what to expect when the field does flip, because no modern human has ever witnessed the event. But we do know that it will happen again, just as it's done for millions of years. For now, it's not a question of if it will happen. Instead, a question of when.